The next group of problems is part 2 of our section 8.1 video, have essentially exactly the same instructions as part 1, except the word substitution was changed to elimination. If you looked at the beginning of my section 8.1 video, part 1, and looked at the instructions, it said solve each system of equations using, instead of elimination, it has the substitution method, and everything else is the same. So we're still finding where two lines intersect, if they do intersect. And the elimination method is really the best method when the x's and y's are lined up. To use the elimination method, you're going to multiply either one equation or both equations by a number to make one letter have the same number with different signs in front of it. So step 1 in the elimination method is to pick a letter to eliminate, and then multiply both equations, one or both equations, by a number to make that letter have the same number with different signs in front of it. So I'm going to pick a letter to eliminate, and I'm going to multiply one or both equations by numbers to make that letter have the same number with different signs in front of it. Usually when I'm picking a letter to eliminate, I like to pick letters that already have opposite signs because I need the letters to have opposite signs. So I'm going to pick y to eliminate. And if I look at my system of equations, the top equation has a minus 3y in front of the y. The bottom equation has an implied 1 in front of the y. I can make both equations have a 3y because I can multiply that 1 by 3 to get a 3y in front of that y, and I'd have the same number with different signs in front of the y. So that's what I'm going to do. I'm going to make both equations have a 3y, one with a positive, one with a negative 3y. Because 3 is the least common multiple between 1 and 3 essentially. So what I'm going to do is I'm going to multiply everything in the top equation by bottom equation by 3. I'm going to leave the top equation alone because it has the minus 3y in it that the bottom equation is going to wind up canceling with. So now in the bottom equation I'm going to go 3 times 2x, 3 times 1y, and 3 times 10. I'm done with my first step. I picked a letter to eliminate. I picked y's because they had opposite signs in front of it. And I'd either multiply one or both equations to make that letter have the same number with different signs. Well, I've made the y have the same number, 3, with different signs. Now I'm going to add the equations together. I'm going to combine the equations to drop out a letter. For step 2, I'm going to combine the equations and solve. So the elimination method makes it so you can combine the equations by just adding together. So I'm going to add together the two equations. The 4x plus 6x is going to give me a 10x. The y's have opposite numbers with the same numbers with opposite signs, so they're going to cancel out. So the y's are going to cancel out, and the 10 plus 30 is going to give me a 40. And now I'm going to divide by 10 and solve for x. So this is the end of my second step. I have x equal to 4. Step 3 is to solve for the other letter. So for step 3, solve for the other letter. In this case, the other letter is y. And you may use any equation that you like. Well, any equation that's part of this problem to solve for this letter. So, I have basically three equations. I have this equation I could use to solve for y, this equation I could use to solve for y, and this equation that I could use to solve for y. They all will give me the same answer for y. I'm going to use this equation because it has the easiest version of the y. So I'm going to use the equation 2x plus y equal to 10. And the answer I came up with, x equal to 4, to solve for y. So I'm going to go 2 times 4 plus y equals to 10. This will give me 8 plus y equal to 10. And then I'll minus 8 from both sides and get y equal to 2. So my answer to this, well, it's a lovely 4, 2. It's going to be x equal to 4, y equal to 2. You don't have to check, but it's certainly never a bad idea to check. So I'm going to take the system of equations that I started with. So my checking, the original top equation was 4x minus 3y equal to 10. The original bottom equation was 2x plus y equal to 10. I'm going to take those two equations and plug the answers in and make sure it works in both. So in the top one, I'm going to go 4 times 4 minus 3 times 2. Make sure that that equals to 10. This will give me 16 minus 6 equals to 10, which is 10 equal to 10, so that works in that one. Same for the bottom one. Put in 4 for x and 2 for y, and make sure that it checks as well. And it does check because it gives me 10 equal to 10. So completely done even with the checking for problem 22. Your problem 21, you should probably do a similar first step. Your first step in 21 is you probably should eliminate the y's, because the y's have one positive in the top equation and a negative in the bottom equation. And the number that you should get in front of the y, the top you could leave a positive 2y, the bottom it's easy to get it to be a minus 2y just by multiplying everything in the bottom equation by 2. So if I was doing problem 21 on my first step, I'd pick the y to eliminate, and I'd leave the top equation alone. I'd multiply the bottom equation by 2 so you could have the y's set up to cancel when you add the equations together. So when I look at 24, the y's have different signs. They seem appealing to eliminate. The x's are also appealing to eliminate because to get this equation to look like that equation, I just have to multiply by 3. There's two ways to get this problem 24 started. And to be consistent with what I do in problem 23, I'm going to pick the x to eliminate. The reason I'm going to pick the x to eliminate is because I'm only going to have to multiply one equation by a number. If I can multiply the bottom equation to make the number in front of the x a negative 6x. Similarly, you'll be able to pick your bottom, you can pick the x to eliminate, because with one multiplication, you could change the number in the bottom equation to the same number with a different sign as the x in the top equation. If we tried to eliminate the y's, because there's no integer to multiply 2 by to get 5, or 5 by to get 2, it'd be messier. So what I'm going to do is eliminate the x. I'm going to leave the positive 6x in the top equation, and I'm going to create a negative 6x in the bottom. I prefer not multiplying by negatives, but I'm going to have to do that here. So what I'm going to do to the bottom equation is multiply everything by negative 3. That would give me the negative 6x in the bottom. I'm going to leave the top equation, 6x plus 2y equal to 26, and go through and multiply everything in the bottom equation to eliminate my x. So I'm going to go negative 3 times positive 2x and get negative 6x. Negative 3 times negative 7y will give me positive 21y. And negative 3 times 24 is going to be negative 72. Done with the first step. Second step is to add these together. 6x minus 6x cancels. 2y plus 21y is 23y. And 26 minus 72, I don't think I can do right now. So 26 minus 72 is minus 46. Divide both sides by 23. Negative 46 divided by 23 is going to be negative 2. So that's going to give me y equal to negative 2. Now I need to solve for x. I can use any equation that has an x. They all will give me the same answer. I'm going to use that equation just because it has small numbers in front of the x. So I'm going to use 2x minus 7y equal to 24. I'm going to plug negative 2 in for y and get 2x minus 7 times minus 2 equal to 24. That will give me 2x plus 14 equals to 24. I'm going to minus 14 from both sides. That will give me 2x equals to 10. And then divide by 2, and get x equal to 5. When I go to write my answer, I write it as a point. I write the x first, which is 5, and the y second, which is negative 2. Kind of checked it in my head and it works fine. For your first step in 23, probably you should also pick the x to eliminate and leave the top with a 4x and create a minus 4x in the bottom so that you can add the equations together and drop out the x's. Our problems 25 and 26 are trickier because 3 and 5 don't have any common multiple. Well, 3 times no number is 5, 5 times no number is 3, 2 times no integer is 5, 5 times no integer is 2. So there's going to be double multiplication to do to drop out a letter. And what I'm going to do, just like you're going to probably do, is I'm going to decide I'm going to drop out the y's. The reason I'm going to drop out the y's is because they have opposite signs in front of them. The least common multiple between 2 and 5 is 10. And what I'm going to do is make the top equation have a positive 10y, because I just multiply by 5 to get that. And I'm going to make the bottom equation have a minus 10y, because I can do that by just multiplying by 2. So if I'm going to drop out a letter, I need to make that letter have the same number with different signs. The least common multiple between 2 and 5 is 10. I'm going to make both equations have a 10y, one with a positive, one with a negative. To make the top equation have a 10y, I'm going to multiply it by 5. And that's going to give me 5 times 4x is 20x, 5 times 2y is plus 10y, and 5 times 3 is 15. I'm going to multiply the bottom equation by 2 to get that minus 10y, because 2 times minus 5 is minus 10. I'll go 2 times 3x is 6x, 2 times minus 5y is minus 10y, and 2 times 1 is 2. Done with the first step. I picked my letter. I made the equations ready to drop out that letter. Now I'm going to add 20 plus 6, and get 26x, and 15 plus 2 and get 17. This is really unfortunate because I'm getting a fraction answer. A lot of times I think I've made a mistake if I get a fraction answer, so I'm definitely going to check this. Kind of halfway done. Now I need to solve for y. I can pick any equation that has a y to solve for y. I don't like equations that have negatives in front of the letters I'm trying to solve for, so I probably wouldn't pick this one. I'm going to pick this one. So I'm going to take the equation 4x plus 2y equal to 3 and plug 17 over 26 in for x. So I'm going to go 4 times 17 over 26 plus 2y equals to 3. Let me do 4 times 17 over 26. So 4 times 17 divided by 26. Math, enter, enter. This gives me 34 over 13 plus 2y equals to 3. Now I'm going to minus 34 over 13 from both sides. On the right-hand side, I need to go 3 minus 34 divided by 13. Math, enter, enter. This is going to give me 2y equals to 5 over 13. Now I'm going to divide both sides by 2. So I'm going to go 5 divided by 13 divided by 2. Math, enter, enter. And I'm going to get y equals 5 over 26. I'm going to write that down as my answer, and I better check because I don't like fraction answers, so I try to avoid them. But for my answer, I'm going to write x is 17 over 26, y is 5 over 26, and I'm going to sneak my checking in. I'm going to use the heck out of my calculator to check. So for checking into the top equation, which is 4x plus 2y equal to 3, I'm going to go 4 times 17 over 26 plus 2 times 5 over 26, and that better be 3. So let me try that real quickly. 4 parentheses 17 divided by 26 plus 2 parentheses 5 divided by 26. That gives me 3, so that works in the top equation. I'll move down to the bottom equation. And into the bottom, since I don't have much room, I'll just write it in. I'm going to go 3 times 17 over 26 minus 5 times 5 over 26. That better equal to 1. So all calculator work again. So 3 parentheses 17 divided by 26 minus 5 parentheses 5 divided by 26. And I get 1. So I know that my answer is correct. Hopefully your 25 doesn't have a fraction answer. So there's likely a hiccup in the video because I made a mistake on 28, and it's not surprising. It started with fractions. It has fraction answers, so mistakes are likely. And I started checking it, and I couldn't find my mistake, so I'm just starting it over. So I'm going to redo this problem, and to make my life easier, I don't like working with these fractions. I can modify any equation before I use it, and I'm going to do that for this equation. I'm going to multiply by 6 to clear all the fractions. So I'm going to take 6 and multiply it by 2/3 x. I'm going to take 6 and multiply it by 1/2 y. Notice I'm writing 6 over 1 to make the canceling maybe easier to see. And on the right hand side, I'll multiply just by 6. I'm going to cancel this 6 with this 3. The 6 is going to become a 2. The fractions are going to be gone. I'm left with 2 times 2 times x, which I'm going to write as 4x. Next canceling, I'm going to cancel the 6 with a 2 and get a 3. Fractions are gone. I'm left with 3 times 1 times y, which I'm going to write as 3y. And to the right of the equal sign, I'm going to write an 18. I'm going to carry down this 2x minus 3y equals to 8. Now I'm going to add the equations together because they're already set up to drop out. The nice thing about this first step is it made the y's ready to drop out. So I'm going to add these together and get 6x equals to 26. Really? And so I'm going to divide both sides by 6. The left-hand side, the 6's will cancel. The right-hand side, that fraction reduces by 2. And if I want to reduce the fraction 26 divided by 6 on my calculator, it would turn into 13 over 3. Now I need to solve for y, and I can pick any equation that has a y. And probably the easiest equation is this. The y's don't have, there's no fractions, and the y is positive. So I'm going to use that equation. 4x plus 3y equal to 18. Substitute 13 over 3 in for x and get 4 times 13 over 3 plus 3y equals to 18. Now I'm going to multiply 4 times 13 over 3. And get 52 over 3 plus 3y equals to 18. And then I'm going to minus 52 over 3 from both sides. On the left side, that's going to leave me with my 3y. On the right side, I'm just going to go 18 minus 52 divided by 3, math, enter, enter, and I get 2/3. And now I'm going to divide both sides by 3. On the left side, I get a y. On the right side, I do 2 divided by 3 in a parentheses, divided by 3, math, enter, enter, and I get 2/9. So my answer, I think my answer is x equal 13 over 3, y equal to 2 over 9. Let me check, and it's a monster to check, so I'm going to use my calculator. To check in the top equation, I'm going to go to the original top equation and plug in 13 over 3 for x and 2 over 9 for y. When I do this checking, I best get 3, so let me make sure that that works. Lots of parentheses. Every fraction should be put in a parentheses. So 2/3 times 13 over 3 for that multiplication, plus 1/2 times 2 over 9. And I better get 3, which I do, so it checks in the top equation. Move on to the bottom equation. Next to that 2, I'm going to plug a 13 over 3. Next to that minus 3, I'm going to plug a 2 over 9. And when I hit enter, I better get 8 when I do it on my calculator because the right side's already 8. So on my calculator, 2 parentheses 13 divided by 3 minus 3 parentheses 2 divided by 9. And I get the 8 that I wanted to get, so I know my answer is correct. For your problem 17, I would recommend starting off by taking the top equation and go 4 over 1 times 2/4 x plus 4 over 1 times 1/2 y equals to 4 times 2. That will make the fractions drop out, and it will make it a lot easier to solve your system of equations. Another horrible fraction set of equations. Let me do problem 29. You can pause the video and do it and then watch me do it, or you can watch me do it if you're not ready to do it. To get started on 29, I'm going to, so I'm not going to do 30. To get started on 29, I'm going to multiply the top equation by 15, or 15 over 1 if it helps you see it, to make the fractions all disappear. When I do that, first fraction, 5 in the 3 cancels, 15 in the 3 cancels, leaves me with a 5. I'm going to multiply 5 times 4x and get 20x. Second, 15 in the 5 cancels, the 15 turns into a 3. I'm left with 3 times 1y, which is plus 3y. And to the right of the equal sign, 15 times 5 is 75. The bottom equation is x minus, I'll say 1y equals to minus 2. I'm going to drop out the y specifically because I have different signs and small numbers in front of them. I'm going to leave the top equation with a positive 3y. I'm going to make the bottom equation have a negative 3y by multiplying everything in the bottom equation by 3. This is going to make the top equation stick at 20x plus 3y equals 77. And then I'll go 3 times x, which is 3x. 3 times minus 1y, which is minus 3y. 3 times minus 2, which is minus 6. So the bottom equation will be 3x minus 3y equals to minus 6. Add together 20x plus 3x is 23x. 3's cancel. 77 minus 6 is 71. It looks like I'm getting another fraction. I shouldn't have written 75 here because 15 times 5 was 75. Not sure where I pulled out the 77 from. But it's going to make a difference here because with the 77, I was going to get a fraction answer. But 75 minus 6 is 69. Now I'm going to divide by 23. I'm going to get x equal to 3 because 69 over 23 is 3. Now I'm going to solve for y. I like this equation because the y is positive. You can definitely use that equation. Any equation that has a y can be used to solve for y. When I go to solve for y, I'm going to use the 20x plus 3y equals to 75 and go 20 times 3 plus 3y equals to 75. This is going to be 60 plus 3y equals 75. Then minus 60 minus 60 will give me 3y equals to 15. and then divide by 3, and you get y equal to 5. So my answer, which I'm not going to check because it's such a nice answer, is x equal to 3, y equal to 5. Alright, so that's everything for 29, so you won't have to do that. Just a few more problems, 3 more problems for this part of the video, and then we'll do a part 3. And your problem 31, you can drop out the x's or you can drop out the y's. It turns out they're both going to drop out. I'm going to drop out the x's. I'm going to make the top have a negative 3x, and I'm going to leave the positive 3x in the bottom. For you, I'd probably do the same thing. I'd probably, if I was doing 31, I'd make the top have a negative 5x and leave the bottom with a positive 5x. It's the smallest multiplication I think you can do that. So to make my top have a minus 3x, I'm going to need to multiply everything in the top equation by minus 3. I'm going to go minus 3 times 1x and get minus 3x. Minus 3 times minus 3y and get plus 9y. And minus 3 times minus 7 and get minus 21. I'm going to leave the bottom equation, 3x minus 9y equal to 4. Now I'm going to add the equations together, and both the x's and y's are going to drop out. We have the same rules for the elimination method as we did with the substitution method. If both the letters drop out and you have a false statement, there's parallel lines and there's no solution, or you can say inconsistent. That's what's going to happen here. The x's and the y's are both going to cancel, so the left-hand side's not going to have anything left. I'll write a 0 there. The right-hand side's going to be minus 17. If both the letters drop out, you're done with your algebra. If it's a false statement, you say there's inconsistent or no solution. If it's a true statement, then we need to write that fancy answer. So my answer to this is either going to be no solution, or I can use the word inconsistent. I wouldn't feel horrible about asking one of these on a test because there's not much to do. It's actually easier than when the letters drop out and you have a true statement. But I generally don't ask these. So I'm going to do something similar for 34. I'm going to make the top have a positive 6y, and I'm going to leave the minus 6y in the bottom. If I was doing problem 33, I'd probably make the top have a minus 8x and leave the bottom with a positive 8x. But you can pick what you want. So I'm going to make my top have a positive 6y in problem 34 by multiplying everything by 3. So I'm going to go 3 times 6x is 18x. 3 times 2y is plus 6y. 3 times 3 is 9. And the bottom is going to say negative 18x minus 6y equals negative 9. On the left-hand side, both the x's and the y's cancel, so I write a 0. On the right-hand side, I get a 0 as well. When you get a 0 equal to 0, you need to write your answer in this form. You need to write your answer as a set of xy such that y equals mx plus b, where x is any real number, because these lines would graph to coincide, and any point on the line is a solution. To get the solution written when you get a 0 equal to 0, if it's not done already, you need to pick an equation and solve it for y. I haven't done it already, so to get my answer written nice, I need to pick an equation and solve for y. I'm going to take this top equation before I did anything and solve it for y, because that looks easy to do. So that's 6x plus 2y equal to 3. I'm going to minus 6x from both sides and get 2y equals minus 6x plus 3. And then divide by 2, divide by 2, divide by 2. And get y equals minus 3x plus 3 halves. Now I can try to squeeze my answer in. My answers for this problem 34 is going to be the set of xy such that y equals negative 3x plus 3 halves, where x is any real number. When you're doing your homework, you should take the time to do this, but I don't think it'll be on the test, so it's not something to really, really fret about. I think your 33 is going to have the same issue, as will I think 35 and 36. Let me just do your 35 and not do 36. So for 35, I can drop out the x's or drop out the y's. I'm going to make the bottom have a minus 2y, and I'm going to leave the top with a positive 2y. The alternative probably would be to leave the top with a positive 4x and make the bottom have a negative 4x. That will work just as well. I'm going to drop out the y's. I'm going to multiply everything in the bottom equation by negative 2. I'm going to leave the top equation 4x plus 2y equal to 6. And then for the bottom equation, I'll go minus 2 times 2x is minus 4x. Minus 2 times positive y is minus 2y. Minus 2 times positive 3 is negative 6. On the left-hand side, both the x's and the y's cancel, so I write a 0. On the right-hand side, the 6's cancel, so I write a 0. So I have to have infinitely many solutions. To get my solution written nice, I need to pick an equation and solve it for y. And I'm going to do that with the bottom equation because it's easy to solve for y. Solving the bottom equation for y will allow me to put the answer in this template. So now I'm just going to use this template. I'm going to say the solution is a set of x, y, such that y equals, and now negative 2x plus 3, where x is any real number. If you want to know more about why we write the solution like this, just stop by my office and I can explain to you as much as you care to learn about why the solution is written like that when you get a 0 equal to 0 or when the lines coincide. So this is a good stopping point. Part 3 would be a good time to take a break between part 2 and part 3 because we start having 3 equations and 3 unknowns. And basically we have to do the elimination method 3 times for each problem as opposed to just 1 time. So get really good at the elimination method before you move on to the next part of the video.